We're excited to talk about map caching today. I'm excited to do this session. There's just so much that's new in version 10.1 that's going to be helpful. And so we're going to, if you come to these sessions in years past that Tom and I have done or others have done, we're going to change the format a little bit today, and we'll just be focused a lot on demoing the 10.1 software. Yeah, I wanted to roam the floor, but I couldn't do that with my laptop.
Hard to do a demo.
Yeah.
You can cache from like an iPad.
So what we'll cover today, we'll be mainly talking about new features in 10.1. We will cover some basic architectures for caching, some fundamentals. We'll talk a little bit about caching on the cloud. We are going to take periodic breaks to ask questions, because we know when you see these demos, you might have tons of questions come to mind. I think we have the latitude to do that as well. It's the last session of the day. We don't plan on running way over time, but we are going to take a break in the middle for questions.
Parties after this.
Oh, the party's next?
Yeah.
Yeah.
So they won't stay.
It's up to you. You want to talk caching or go to the party? Want to throw dodgeballs at yourself or talk caching? So I'm going to just launch into a demo of new features at 10.1. Here's a rundown of stuff you will see. I'm going to explain how caching has been offloaded to a new geoprocessing service that gets installed with ArcGIS server. I'll also show a new user experience for defining cache properties. We tried to make this more approachable for beginning cache users. Also, this experience is used to define caches that you build in ArcGIS Online. So it's a shared experience preparing caches for ArcGIS Server and ArcGIS Online. They use the same type of interface. I will show some of the utilities that have been put in for estimating and calculating cache size. These are helpful to help you get an idea of how much you're about to generate when you click Go on building your cache. We've also made the ability to decouple the caching from the ArcGIS application, so you could close ArcMap and come back to it later and check on the status of your cache. You're basically just sending a cache job to the server, and then you can come back and check on it later and get the status. You can also view real-time reports as your cache is building and fix problems that may have arisen that were reported by the server. And finally, I'll show how you can visualize your cache creation over time and go back and analyze how it went with building your cache. So to get started, I will start actually in ArcGIS Server Manager. This is 10.1 Manager. I really like it. It's been rewritten in HTML and JavaScript. Now there's no separate .NET Manager and Java Manager. There's just one manager. And the thing I want to show is in the Services menu. I have a couple of folders here containing services, but by default, when I create a site, I get the System folder and Utilities folder. And in the System folder are some services that you should just leave there. You can change the number of instances, but these help with fundamental things on your server, like publishing services. And then caching tools is used for building caches. If you want more power when you're building caches, you actually increase the maximum number of instances of this service, not the map service that you are caching. So that's a change. Also, something that's new is this maximum instances is the number of maximum instances per GIS server in your site. It is not a total number of instances for your site. It is just per machine. So please be aware of that. This reporting tool service is also necessary. It helps report the progress of your cache as you build it. I'll show an example of what's contained in those progress reports a little bit later on. Here's a map that we'll be caching today. This is Hamilton County, Indiana. The founders of Hamilton County were very foresightful because they made it in the exact dimensions of a tile, and it's very good for caching. So we're going to show that today, but I will mention how you can use an area of interest for an irregular shape. Looking at this map, you can see some of the design work that's been put into it. Some of the features have been symbolized differently depending on the scale that you're viewing. That's a best practice for caching. Really, you should decide on the scales that you're going to use before you go and try to build the cache. You should use those scales even when you design your map, and if you want, you can go ahead and load them into this drop-down. For example, if I knew I was going to make a map with the ArcGIS Online scales, I could load them in like that, and then I could make sure that I always did my design work at those particular scales. Notice as you get down in this map, it's got a little more detail of the different layer types. So those are just some fundamentals. To go ahead and publish a service at 10.1, you use this wizard just from the File menu. Publishing always starts in ArcMap at some point with a map document. So I will share this as a service. I'm just going to publish this with some of the default settings. Choosing my server here. This is Wednesday demo, so we'll name it that. And when I click continue, it's going to take me to a dialog where I can now set up all the service properties and analyze my service for potential errors or warnings that would prevent me from publishing or that would affect my performance. At this point, it is creating what is known as a draft service. Sometimes it takes a while to analyze your service and fix all the errors and warnings. It may take more than one session of work. So if you want, when you close this dialog, you can elect to save a draft service, and then you can come back and keep working on this until the time that you are ready to publish, at which you would press the publish button. I won't show all of these properties because that's not really the purpose of this session, but I do want to show that the caching menu, which looks somewhat similar to what you've seen in past releases, in that the first thing you choose is to draw the map service using tiles from the cache. But it is different in some ways, that it has this concept of minimum and maximum cache scales. It will ask you to choose the tiling scheme. If you choose ArcGIS Online, Bing Maps, Google Maps tiling scheme, and your map is not in the appropriate projection, which is Web Mercator Auxiliary Sphere, it will create a copy of your map in that Web Mercator projection. So you will no longer get an error if you try to use this ArcGIS Online tiling scheme with and you're using the wrong projection. So that's one thing that's new. If you don't want to use this tiling scheme, you want to use your own, you should go in and create your own tiling scheme using Generate Map Server Cache. So that's down here in the Server Tools, Generate Map Server Cache Tiling Scheme. That's down here in the caching tool set. You'll see Generate Map Server Cache Tiling Scheme, and this tool will allow you to type in all the scales that you want, and from there on out you can save that tiling scheme anywhere you like, and you can go browse to it using a tiling scheme file. The suggest option is good for testing and prototyping. It will just suggest some scales for you based on the scales of your map. However, we don't recommend using this for most of your production maps because, like I said, you should choose your scales back even before you start designing your map document. So it would not be a good practice to design a multi-scale map, and then click suggest, because it might suggest scales at which you had not prepared for in your design work. When you choose to cache a map and you choose your tiling scheme, it will examine the layers in your map, it will examine your extent, and any scale ranges that you have set, and then it will suggest a minimum and maximum cache scale level. Now, this area outside the suggested range will still be in your tiling scheme, but people will not be able to create, delete, or import tiles from those other scales. If you want, you can later go in and expand the range. But typically when you create a cache, you have an idea of what level you want to stop creating tiles at. You might want all the scales in your tiling scheme just for conformity. I want to conform with Google Maps tiling scheme, so I put all 20 of these in. But I know that I don't want people to go generate beyond the 1 to 4,000 scale, for example. So that's what these sliders are for. You may be wondering what happened to all the advanced settings that you had in the past. These are all still available using an advanced settings tab. And there's even an advanced button on the advanced tab if you want to get really advanced. This is stuff that you should probably not change. That's why they hid it back here. Yeah, it's really going to be called that at final. One thing that's a good practice is you might want to uncheck this box if you're just using one machine to build the cache, using local cache directory when generating tiles on the server. when you're caching with multiple machines, it's helpful to create the tiles on that machine and then copy them as a group into the server cache directory, rather than having everybody write into the server cache directory at the same time. So this box causes that to happen. And if you have a multiple machine deployment, you want to leave this checked. If it's just your own machine, just one machine, you can uncheck it. Other items on this include the cache directory where you're going to place these, and the area of interest. So if you want your caching jobs to default to the boundary of a feature class, you could import that right here. And so if your county is not the shape of a tile, you can go ahead and upload that at this time. Also, it will look at your map and it will attempt to suggest a tile image format. In this case, I think it found a raster layer in the background, a hillshade, and it suggested mixed, which creates JPEG in the center of the cache and then PNG32 on the periphery so it can get the transparent edges. A new format here, we've always had PNG8, PNG24, and PNG32. A new format is PNG, which as it creates tiles, it attempts to analyze the tile and pick the bit depth for the PNG that is the most efficient. So it takes a little longer to cache using this option because the tiles must be analyzed as they're created, but the resulting cache tends to be smaller. So because it uses the most efficient bit depth as it goes from tile to tile. So that's something you might enjoy experimenting with. If I'm going to make a mixed or a JPEG cache, I want to make sure the JPEG quality is high enough for my vectors so that my lines and labels look good. So in this situation, I like to bump the compression or the quality up to 90 from the default of 75. If you're caching imagery, Tom and I have found that you can lower this quality to something like maybe 55 or 60 without significantly affecting the quality of the tile to the naked eye. And that can really save you a lot of space on disk. So for vectors, you want to increase the quality. For rasters, you can, for images, you can lower it. So once you set up all of that, you're ready to make a decision. And this is a new decision that you're faced with at 10.1. Do you want to build a cache automatically when you publish the service and just have it start making tiles right away? Or are you going to go run the caching tools yourself and build it manually over time? If you have a smaller cache, it can be nice to just have it kick off and start running the cache automatically. If your cache is larger, then I suggest you wait and build it manually in stages. You'll probably want to run at least 2 separate jobs. One job to cache the small scales, the zoomed out scales, at the full extent of the map, and then a separate job for the larger scales to cache just your areas of interest. Each time you run the caching tools, you can override that area of interest. And so as you go down with larger and larger scales, you'll probably submit narrower and narrower areas of interest where you create the cache. Many people have come up to the showcase and told me stories about caching for weeks or months on end. Many times, those individuals could have reduced the amount that they were caching at the large scales, especially when no data is available or the resolution is poor on the data when zoomed in that far. So you should really be judicious as you zoom in about what you cache. I think I'm repeating stuff that you're going to say, but Tom's going to show. He may show some stuff about that later.
I can skip it.
Okay. Show the diagram if you have that of the California when you get to that point.
Oh, yeah.
Anyway, it will look, and to make this decision, you might want to understand about how big of a cache you're going to have. And we haven't really had good tools for this in the past other than saying, go create a test cache of a known area and then extrapolate from your test cache. Now you'll get a crude estimate like this. This estimated cache size is just derived from the image format that I used and the extent of my cache. You really ought to just run this utility, calculate cache size, and this will give you an even better estimate because it creates sample tiles and then extrapolates from those sample tiles. So you can even choose the quality of estimate you make. I'll choose best. The quality that you choose determines the number of sample tiles that are generated. And you can see that on level, it's starting from the bottom level and it's creating sample tiles. And then it's putting an estimated range inside of here. So in the end, it doesn't give you a magic number of exactly how big your cache is going to be, but it does give you a pretty reliable range. And you should note this range and use it to help you make a good decision about whether you are going to kick off the job automatically or build your cache in stages, or if you want to narrow down your caching at some of the larger scales. Note that this utility does not take into account a feature boundary that you use to narrow the cache. So you will need to just remember that it's looking at the rectangular extent of your map. So okay, I've calculated my cache size, and I think I'm ready to go. So I'm going to choose to build the cache automatically when it's published, and we'll just go for it. So at this point, it's going ahead and creating a service definition, which is a file that's used at 10.1 to publish any service. This service definition is placed on your server in a particular directory, and then it's unpacked, and a copy of the map is available on your server, and that's what the service will use. Once it's done with all this stuff, you should see a message here that it's done publishing the service and it's ready to start creating tiles.
Is this our first caching demo in this session? Like in our other sessions, have we ever done a caching demo? We don't usually like to do caching demos in these because they
in the advanced session we rarely did. Yeah. Who likes to watch that bar go around and around? Right. Well, I'm going to show something a little different. So instead of a bar going around and around, I just get this message: hey, your service is done, and I published it, and now I'm starting to generate cache. And I don't really see anything. I could go ahead at this point. If I wanted, I could look at the geoprocessing results window. Let's bring that up. If I expand for the current session, you'll see that it's doing a couple things. It staged the service, it uploaded the service definition, and now it's running manage map server cache tiles. This is the caching tool. And when it's doing that, I can just go ahead and close ArcMap, and the server is still working on that. This caching tool service is processing and it's building the cache. Now I'm going to open this right back up again. You might say, how do you know if your cache is done? How can you do that if your ArcMap is closed? This is running asynchronously, meaning I can come back at any time and retrieve the status of the caching job. And so I want to show you some of those tools that you can use to get real-time status updates. So I have a connection to my ArcGIS server over here. And let me expand that. Here's the service I just published. At any time, I could right-click this and choose View Cache Status, and it will give me a brief summary of just what percentage of my cache is done, and then whether tiles are still being created or not. Now, this takes a few seconds to get warmed up, as it pings the server on a regular basis. You have to wait for it to do the first one. So showing details, well, what I'm seeing up here does not match what I'm seeing in the job progress. So I don't know what happened. But I can figure out that 2 scales were created, and it's telling me that these 2 are in progress. I honestly don't know why this says 0%.
It's because we're doing a demo.
Yeah,
this
the demo
could be why we never demoed this stuff.
Yeah. It's in beta.
Yeah.
One thing that's cool is you can go in and look at the job status. So here's the job I submitted. And okay, this is telling me that it finished 18% of the job. I've got an ID associated with this job, but if you were to run multiple runs of the caching tool, you would be able to see multiple jobs here, and you can see a history of the jobs that you've done. You can cancel the job if you want, and then you can start up more caching later. Oh, hey. It's increasing, even though tile generation is not in progress. You can, if there are errors reported, for example, many of you might have seen geoprocessing messages about I failed to manage tiles for these certain extents. You can right-click here and just choose Fix Errors, and it will go back, and if it's logged a failure at a certain over some certain extents, it will go back and fix those errors. You can also export those errors to a file.
Did you guys hear that? I mean, I don't know, that's kind of mind-numbing for me. So any of the errors that it happens along the way, you can just click Fix Errors.
Yeah, in the past you just got a textual report of the errors, and it was difficult to harvest that.
They should be doing backflips.
Yeah, if this was working, I'd be doing a backflip. Anyway.
Why does it automatically fix the error? Why don't you skip
Well, good question. If you have an error in a certain spatial area and you rerun it and there's still an error, you might run into a loop where if it just automatically kept trying to fix it, you would hit that loop. So,
maybe one retry.
One retry. Yeah, I can see that.
It is something that
point.
I think we've discussed and maybe looking at in the future. For right now, it's kind of easy. It's just to at least give you the ability to fix them, as when you see fit.
One thing that's kind of hard for me to decipher is this job ID. So if you lose track of what job was what, you can look at details. And this will show you all the parameters that you used when you fired off the caching job. So it'll show you the extent that you created and then what parameters you put in. It looks like it created some more. And I still have a very small percentage of my cache completed. So I think this status is wrong. This is incorrect, but this up here percentage could be more accurate. As I go down, you can see how many tiles are going to be placed in these higher levels, and this gives you a real good idea of how the tiles are distributed among levels. A lot of times we'll have people say, "Well, it did the first 17 levels just fine, but the next 3 it ran into problems." And usually that's because those larger scales have many more tiles, and sometimes it can catch you off guard how many tiles are actually there. So I'm actually going to cancel this job. You get the idea of what's going on. My server is running kind of slow. In the past, I've been able to cache this faster. So I'm just going to end this so that my CPU isn't chewed up by creating cache. So I have canceled this. I do want to show a little bit about tracking the status of your cache. One of the options that you will not see at 10.1, well, let me open the caching tool. Oh, let me show you this way. You can right-click any service and choose Manage Cache, and then you have shortcuts to all the caching tools here. So you don't have to remember what their names are. Like I was trying to decipher which one should I open, and it's a little bit easier to see it this way. And then when you open these tools, it should have some of the information filled out from context. So it knows exactly which service I'm dealing with, and it can fill out some of these parameters. Notice that here I'm limited to the scales that are within that cache scale range, and I also have that crude estimate. Although you should run the calculation utility to get a more accurate estimate than this. This wait for job completion checkbox, that's where you can choose to allow the asynchronous caching. If you leave this checked, you'll have to keep ArcMap open or ArcGIS open while you make the cache. If you uncheck it, which is the default for automatic caching, then you can close ArcMap like I did and come back later. The area of interest allows you to override whatever area of interest you set for the service as a whole. So on any particular run of this tool, you can override the area of interest, and you can even digitize an area of interest on the screen. If you know that you need to just patch up a certain area, it can be nice to just draw a box around it. One thing that's not here that you might have seen in the past is a checkbox for tracking status of features as they are cached. The feature tracking and the status tracking is done a little bit differently in 10.1. And the way that the different SOC processes are assigned to the different bundles is a little bit different as well. In the past, this is more of an advanced topic, but in past sessions you may have seen that one SOC process was assigned to one bundle of tiles. And so if you had a small feature that had only one bundle in it, you would only have one SOC process doing anything. The rest would be sitting there idle. In 10.1 we have changed that such that the SOC processes are used in a more efficient way and they work on all features at a time. One side effect of that is we don't have the traditional status tracking that we've exposed on this tool. However, there is a different way that you can view the progress of the cache, and I think this is pretty cool. Inside of your cache directory, you can see some caches that I built. Here's the one I built today. If you drill down far enough, you'll see this status.gdb. This is just a file geodatabase containing status information about what your caching tools are doing as you create the different bundle files in your cache. A bundle file is just a large file that contains a bunch of tiles inside of it. You can take that status.gdb and copy it to a location. So before this session, I went and I made a very large, or larger cache of Hamilton County. I went all the way down to 1 to 2,000. That encompasses a number of bundles. Then I went and copied this status.gdb and I went and put it in a different folder. You have to go put it in a different folder because if you try to browse to a cache here, you get a raster layer by design. You could drag and drop this into ArcMap. So there's a little tip that you might not have known. But you can't see that status.gdb if you browse in our catalog. However, if you do it in Windows Explorer like I just showed, you can take that file geodatabase and go put it into a folder wherever you want. So here's my status.gdb. And I've got a feature class in there called task status. So here's Hamilton County. And at first this looks very rudimentary. If you open the data, you can see that there's a lot of rich information behind this about the different bundles that were created. Each row represents a bundle in my cache. And you'll note that there's different fields like scale. So at the smallest scale, I just have one bundle. Notice at the largest scale, 1 to 2,000, I've got all these bundles down here. So as you zoom in, you get more and more bundles created. And then I have an exact tile count for each bundle. I also have the name of the bundle and some timestamps about when it started and when it ended. So I can harvest this information in a lot of interesting ways. One way that I can do it is maybe view some time series data of how my cache was built. So I'm going to go in and change a few of the properties of this feature class just to make it easier to visualize how my cache was built over time. I want to symbolize each scale with a little bit different color, and we'll see the cache change from blue down to yellow as the different levels are built. I'm also going to make this time aware, so I'm going to utilize those start and end time fields and try to play an animation of my cache as it was built. Let's go ahead and change the time step interval. So we'll look at what changed every 5 seconds during the creation of this cache. Whoops, I've got to reset that. If you look closely, you'll see that this cache took about 10 minutes to create. Okay, so now that I've filled out that information, I can open the time slider bar. Let's set just a couple properties on that. I'm going to slow down the playback a little bit. Okay, and then just to make this even a little more interesting, I'll put labels on the bundle files so you can see what the name of each bundle file as it gets created. Okay, so if I were to drill down in my file system into my cache directory, I could find this bundle file, and I could also look at its status down here inside of status.gdb. Let's see what happens when we play this back. So each tick represents 5 seconds of time. And at this point, it's creating several bundles at once for several different layers. That's why you see two labels on there. As it gets down to the lower levels of the cache, you can see how it takes a little bit longer to build each bundle because it's packing more and more files into the bundle. This is also a good exercise to see how your server is dividing up the job and the progress of the job over a spatial extent. Sometimes we find that geography affects caching, and maybe you have a feature in your map that's causing a crash or a problem data source in a certain area of your map. And so as you watch the progression of these bundle files, if you see a certain bundle hanging or being completed with too few of tiles, you could glean some information out of this task status. So I encourage you to use that status.gdb to your benefit. It's really, at this point, it's not a heavily documented feature. It's something we wanted to show at Developer Summit because we feel like you could utilize it. In the future, the caching team wants to take this status.gdb and provide some visualization right inside of the ArcMap UI directly. But I would encourage you to know that this geodatabase is here and that you can use it for your benefit. Now that was a lot that we just showed, and I'd like to take a short break and just allow you to ask some questions if you had any that popped up during that demo. Go ahead.
Are the maximum number of instances, are they being used, or are you in 10.1, or is it, I mean, like, you know how you said the minimum number of instances, maximum number of instances, is the caching using those blocks of instances in 10.1?
The question is, does caching use the maximum number of instances? It uses the maximum number of instances of the caching tool's geoprocessing service, not the map service. And that's a difference between 10.0 and 10.1.
But along those lines, so there's kind of two things. When you run the job, you specify a maximum number of instances. That's the total number of instances that can be used. That geoprocessing service defines the number of instances that can be used per machine.
So that does not affect
Yes.
the map service?
No, it doesn't affect your map services.
Other question? Go ahead.
Where?
Do you still recommend the n+1 number of instances for the maximum instance for the
The formula is changed for recommended number of instances. We've documented it in the 10.1 help. I can't repeat it to you off the top of my head.
In version 10, it was like recommended the number of cores +1.
Yes.
Yeah, and I believe that's still the same.
That's as good a starting place as any. That formula was derived after a lot of people had used the software and been put under heavy testing. We're doing that with 10.1 and working on deriving those recommendations. But that's as good of a starting point as any, and then go from there. Even with that figure, you still had to use some trial and error and watch very closely your performance. That wasn't a magic number, but it was the best place to start.
Let's take one over here. How about back here?
Caching on demand with compact cache had poor performance. I'm not aware of that, but I could talk to you. I'd be interested in talking to you afterwards about it. And I could find out if that was a logged bug and get back to you. Yeah, we'll take one more, and then we'll go into Tom's, and then we'll have another question session. Go ahead.
For local government and like campus applications, we tend to sometimes have to go to level 20 or 21 even. Do we have that on the interface? I saw it only like 19.
Oh, okay. The question was, could you go even farther down than 20 and 21? If you load just the pre-made Google Maps, Bing Maps tiling scheme, you'll just get those 20 levels. But you can create your own tiling scheme that starts with the Google Maps and then add your own down below. Yeah, and then you could drag that green slider bar all the way down to the end if you knew that you were going to create all those levels. Yeah, we'll turn things back to Tom, but we will come back to questions at the end. So we'd like to get to them all.
Yeah, thank you. All right, great. So what am I doing sitting down? I'm not going to sit down. Let's talk about architecture for caching, some of the changes that happened. Oh, that's not right at all, is it? It's kind of a cool car, though, right? How's that? Was the other one better? You sure? It's like, no, go back. All right, some changes in 10.1 architecturally that you can take advantage of with caching. So as Sterling said, that there's now this geoprocessing service that handles the actual tile creation. That's true. And in addition to that, there's the ability within ArcGIS Server 10.1 to have clustering, which allows you to isolate certain machines for certain services. So I can have one machine sitting on one cluster, another machine sitting on another cluster, and I can specify which services are going to run on each one of those clusters. In that way, you could isolate your caching job to its own machine or set of machines and completely isolate that processing from the rest of your services, so that those map services can continue to have tile requests while the cache is being created, and you'll get good performance the whole way through. The overall performance of the system won't degrade while you're doing your map caching. Now, this is that's certainly a new architectural option for you. This slide is true in 10 and 9.3 and before, in that one of the ways that we recommend building cache is by taking advantage of your staging server that's running behind your production ArcGIS server. If you share your cache directory between those two machines, say using a SAN or something, sort of a file storage, you can point them both to the same cache directory and be building the cache on the staging server while you're serving the cache from the production server. So it's a similar idea to what we showed you in the last session, or the last slide with clusters, but it's using two separate servers with a shared cache folder. Notice there's a subtle difference here on this slide. This gives you the added capability of having different content in your map services on the staging server than you have on your production server. In general, that's not a great idea to do indefinitely, because you're kind of ruining the whole purpose of having a staging server. But it gives you the ability to have a more complex map being used for your cache creation, but a simpler map used for serving your tiles out. And if you've ever built a base map or something like that, you can end up with lots and lots of layers in that map document, and you may not want to serve that out with the cache service. So you can reduce those number of layers, put that map on your production server, but have it use the exact same caching folder. Now, one of the recommendations that we've all used, and Sterling talked about a little bit there, was being smart about, or thinking about where you actually need to cache your map. The example like Florida. Florida is the perfect example that, if you just go and you treat Florida like Hamilton County, you're going to end up creating a whole lot of cache tiles out in the Gulf, right? Because, and although I like going out in the Gulf, I'm probably not going to zoom in on a piece of water at 1 to 1,000 scale. Okay, that's just not exciting to look at, and you could double the size of your overall cache in the amount of time that it takes to create it. So think about where people are going to be interacting with your cache, and just build the cache in those specific areas. Sterling did this great analysis of California and where people may zoom in and look at a map of California. There's one rule for everyone that ever goes and looks at a web mapping application or any kind of application on the web. Where that rule is that they always zoom into the same location. Do you know what that location is? Yeah, they always zoom into their house. It's like, I've done tests with this. It works every time. You just put it up and people will go. But and what's that tell you, though? That's what they're interested in. They're interested in where people live and transit. So if you're doing a kind of something that's for the general public, a kind of commercial service that's available for the public, you'd be best served for considering where people live and where they drive. And that's what this analysis was all about, is buffering those population centers and transportation corridors to find out where to build the cache. And this is still true this is always true, right? The easiest and the fastest way to do anything when we're talking about performance is to not do it at all, right? So that's what we're saying to you. No matter what version of our software that comes along, it will be faster to do less, okay, as long as it's satisfying the overall goals. And you can see it can drastically save on the amount of time that it takes to create tiles. And Sterling showed you where you just put in that feature class. Now you can mix these together so that you can use caching on demand in conjunction with caching by feature class. So I'm going to use a feature class to define where I'm going to build my cache, and then I'm going to use cache on demand if anybody decides they want to zoom into the ocean or the desert or something like that. And what happens with cache on demand is that, as they zoom into one of these very exciting places, the server will cache that and deliver those, cache it at that time. So the first person that zooms into it will get less than pre-cache tile performance. Hopefully not as bad as we may have seen in the past, but it'll generate those tiles on the fly and then deliver them to you. Before I go into this, one other thing on cache, using cache by feature class that I didn't talk about, is make sure that you simplify that polygon that you're using, or those features that you're using to define the areas where you cache. Things that are bad for doing cache on demand. Your parcels layer is a bad candidate for doing cache on demand. Just mostly because it has too many vertices. It doesn't need that. So if you have like a study area or something like that defines the boundary of where you want to cache, that's okay. Now, one of the things that's different at 10.1 is we don't really care so much about having lots of features. So if you do have lots of features in that feature class that you use for cache by feature class, that doesn't impact it quite as much as it did at 10.0. But generally, you want to have a simplified polygon defining the area where you're creating your cache. Dealing with no data is exactly the same as it was at 10. You have a no data tile that you can drop into the all layers folder, and it will show up when you zoom into those areas where you haven't built a cache. That's assuming that you haven't done the cache on demand. Now, some of the other things that kind of exciting at 10.1 is caching in the cloud, and you could do some of this at 10.0, but it's certainly enhanced at 10.1. So we'll talk a little bit about what you can do there. In general, I mean, if you went to the plenary, well, you talked a lot about security, but the overall benefits of cloud computing are pretty clear, especially when it comes to processes like caching that are extremely intensive, because with the elasticity of the cloud, the system can scale up to accommodate that job and then scale back down to accommodate your normal request. So you can take advantage of that scalability with caching jobs. Now we have the way that you deploy it. Of course, we have kind of the overall process is you create this machine image in Amazon, you license it, you put your data on it, you might clone it, and then spin that out in Amazon. That has been greatly simplified with the Cloud Builder application that you can use for interacting with Amazon, and I'll show you that here in a second. This is what it looks like. It's an application that's kind of wizard-driven that allows you to create these machines in the cloud. One of the things that I like about it is that it makes it real easy to spin up Linux machines in the cloud. I'm not a Linux person. I learned GIS on Unix, but that was a long time ago. I've slept a lot since then, so I can do ls-l. That's what I remember. And that works, but that doesn't help me very much. But this Cloud Builder allowed me to create Linux machines in the cloud, and with 10.1's architecture, I never have to log into that machine. This will create an administrative access to Arcgis server in the cloud, and then I can work on my Windows and publish to that Linux box and let it build cache and serve out tiles and do all that kind of fun stuff. I like that because it's also half the cost of Windows machines in the cloud. And that's a pretty straightforward formula for love in my book. So it's a great tool for that. It takes care of all the licensing, and it also takes care of auto-scaling. So you can put in rules in, and we're showing that panel here, the rules for that when the machine reaches a certain saturation, like the CPU has an average usage of 80% for 5 minutes, spin me up another machine like that one and add it to ArcGIS server. And then run that for a little while, and if they run up to 80%, just spin up another one. and you can set up maximum number of machines that you want to use in the cloud. But that's kind of the elastic architecture idea. I can monitor the performance of this machine. When it hits a certain amount, spin up another machine and keep adding machines until I satisfy the request. Within reason, of course, based on your budget. But the other thing to think about is be careful. Don't go crazy with this. Don't say, well, if it hits 50% in 1 minute, go. Because you could get a spike for 1 minute and end up spinning up another machine, and you're paying Amazon for every one of these machines that you spin up. So just kind of be cautious about that. You don't want to have all of a sudden have 15 machines laying around because you misused these settings. Sometimes even when it just starts up, it might be running some processes, and that could make it run at a higher CPU for a minute or so, and then that would just spawn additional machines. So just the defaults are pretty good. 5 minutes at 80% are pretty good, so you might try those. ArcGIS Online is kind of a new thing. With ArcGIS Online subscriptions, we can now publish tiled map services to ArcGIS Online. That's kind of the subscription plan for ArcGIS Online. This is a different animal than really everything else we've been talking about. Yes, it creates tiled map services, cached map services, but this isn't ArcGIS server like we're used to. And when I go through the demonstration, you'll see it has slightly different parameters that you can control. Things are the same, like the scale levels and file format and all that kind of thing, but you just have a little bit less control over some of the parameters on it. The nice thing about this is you don't have to worry about how many machines you use. It's mostly about the amount of storage that you're using. So you don't think, oh gosh, am I going to use 5 machines or 10 machines? Whatever, you just submit it, and ESRI takes care of building those cache tiles. But you're charged by the storage, so be cognizant of how many tiles you're creating. So now I'll do a quick demonstration showing you caching using Amazon. What I'm going to do is I'm going to log into one Amazon machine. I've got another Amazon machine that's a gigantic Linux box. I'm going to submit a caching job over there and have it do some imagery. I'm going to cache image services, which is new at 10.1. And then I'm going to submit another job to ArcGIS Online, yet a different cloud. This is an all-cloud demonstration, so if I lose network connectivity, we're going to the party. But I'm going to publish that to ArcGIS Online, and you can see what that process looks like. So first thing is I'm remote desktop into a Windows machine in the cloud. This has this is a pre-release version of 10.1. I'm going to start with a shaded relief, and I know it's kind of weird for Indiana. There is some elevation change in Indiana. Not so much up here where I live, but there's a lot down here. It's very beautiful. You should visit it. You can come and visit me. But over here, I have on the right, we have some different mosaic data sets that I've created for Indiana imagery. So there I've got the hillshade that we're looking at in the map. I could just right-click on that and share it as an image service. So this is similar to the process that Sterling went through. I'm going to publish it as a service. And here I'm going to pick the service that I'm working with. There's that Linux machine. I'm publishing it over there. When I click next, it's going to connect to that machine, and away we go. I was having some issues this morning. I think there's some network connectivity going in between these machines. Like every once in a while, it would do exactly this. So I may do a little dance, talk about the party. I'm sure it'll be good. Dodgeball. Anybody playing dodgeball tonight? Excellent. All right, good. All right, maybe we'll go over to ArcGIS Online. Do that part of the demonstration. So here I've got another map service. That's the great thing about working in the cloud. You can just switch over to a different cloud. So here I've got hydrography for Indiana. And I've applied a pretty complex symbology here. So I'll zoom in here and you can see this symbology, this shading effect that we're applying to this. And that's why it kind of takes a little while for it to draw. So it can be a pretty good candidate for caching because I may want to display it at some of these smaller scales. Go back over here. Okay, excellent. I'll get back to that hydrography. We'll publish that to ArcGIS Online in just a second. But I wanted to kick this one off. That was just enough stalling to get us to the next level of this wizard. So we're publishing that image service, and you have all the parameters for image services in here. And this isn't an image service session, so I'm not going to go into a lot of those details. But this is a new thing. I can cache that image service. Now, just because you can do it doesn't mean this is necessarily something you should do on all of your image services, but it is an additional option. Image services perform extremely well in web applications and over the web, so you may not need this. But if you do want the added performance of caching, by all means, it's a great way to go. One of the nice things about caching image services is you don't have to necessarily create overviews for your Mosaic datasets before you create the cache. So if you know that you're eventually going to create a cache for this image service, you can create the Mosaic dataset, don't create any overviews, publish it, and start building cache. And the reason for that is because image services build cache completely opposite from map services. They always start at the bottom. They start at the largest scale and work their way up to the smaller scales. So since that largest scale is visible without building overviews, it builds that, and then it builds all the other tiles on top of it. So you can go, if you know you're going to a cache, you can go from a Mosaic dataset to a cache very, very quickly, which is kind of a neat thing. But one of the things you lose when you cache your map service is you lose the ability of the image service to change its raster function. So one of the nice things about image services is that they allow you to change the compression and change all these characteristics of the image service per request. You're not going to get that if you cache it. So understand that before you cache your map service, and then you can continue on. But if you do decide to cache the map service, I can use these sliders just like Sterling did. I'm going to build the cache automatically. There's some advanced settings here that I can go in and specify the image format. Go in there and right in there and just specify that image format if I want. I go right ahead on in there and just specify that image format. It's right in there. You can trust me. It's great. All right. Why is it doing this to me right now? This is awesome. Okay, so this is kind of a tale of two map caching jobs. We're going to go back to ArcGIS Online. Golly, what did I do to deserve this? I don't know. So, all right. While that's thinking, I'm going to publish this service to ArcGIS Online. So a slightly different scenario, but I'm going to go through here. And I've signed in as me, Tom Brenneman, and I'm going to share this as a service. And here you see that not only is that server that I created, that I just published, or I'm trying to publish to there on the other map document, but I have my hosted services. This is my ArcGIS Online account. And I have a colleague right now who is doing a demonstration elsewhere with this account for apparently Douglas, Omaha, because I opened this up this morning and everything was Douglas, Omaha, so that's kind of fun. Fun for me. But you see, when I publish to this, I'm publishing it to ArcGIS Online. I have kind of a different, kind of a subset of the capabilities that you saw when Sterling did this part of the demonstration. I can either do feature or tile mapping. And then when I go into tile mapping, I can see in the caching section, I can see the same kind of sliders. So I can go in here and say, I'll make this 13, make this whatever. and then I can calculate the size of the cache. Now, this is what's really important. I'd say more important here than anywhere else. I'll just do good. Because, like I said, you get charged in ArcGIS Online based on storage. Now, I don't have all the details on how that's going to work out, but as far as the actual charging, but we do know that there will be some, of course, if you store more in the cloud, it costs more. So that will be something to consider when you're publishing these services. So these tools can be very beneficial for estimating exactly what it will take to cache that in the cloud. And when I'm ready, I can publish this thing to ArcGIS Online, and it's going to copy the data up to ArcGIS Online and start caching that service as soon as it's published. Now, back to the other caching job. There, as I said, you can choose the image format. All that just to show you can cache the image format. I'm going to publish this one over to the other ArcGIS server machine once I just click publish there. So Sterling, this is the slowest that it's ever done this, and good thing I picked a extra large high capacity machine for this when I set this up. Yeah, that's excellent. Well,
that is a good idea though. If you need like a real powerful machine for caching just for a short amount of time. We have folks who tell us, well, I've got this extra box in the back room and I have to use that to build cache and it takes a long time. If you look at some of the specs of those Amazon EC2 instances, the virtual machines that are available, some of them are very powerful and they can generate tiles very quickly. So it might be worth the cost to rent one of those for one day or even 1 week to generate millions of tiles and then be done with it.
Yeah.
Once you've copied those tiles back onto your back on premises, you can terminate that instance and you don't have to pay for it anymore. So in the end, it may be more cost effective just to get a powerful cloud machine. And I believe that's what you're doing when you've got that really large Linux.
Right.
Linux
yeah.
instance.
Exactly. So, yeah. Now, apparently there was some errors in the map. That's why I was having some. I needed to put in a summary and tags, which won't be there in the final, but is there right now. But yeah. So I created this. I don't know how many core machine up in Amazon. And it can build all the tiles, and when I get done, I can take a snapshot of it and then serve it out through a smaller machine for the duration. So I can use a huge machine to generate the initial cache, and then kind of take that and scale it back down later. So right now, with ArcGIS Server in the cloud, it's copying my imagery up to that cloud machine, and then it's going to start building that cache on that cloud machine as soon as it gets done processing here.
And this could open the door to you. Even if you don't know how to, use Linux or log in and type commands, this ability of you to copy data to the server and just kick off a cache immediately might allow you to take advantage of some of that, some of the large Linux instances, even if you're not consider yourself a Linux pro.
Right, like me. I am certainly not a Linux pro, but this is a Linux box. And I created it here with this application, the ArcGIS Server Cloud Builder. You can see that I'll click Update on this, and we can kind of step through some of the settings for it. This is a high CPU, extra large, 7 gigabytes of memory, 20 computing units, high I/O Linux box. The biggest one, I just scrolled to the bottom when I picked it.
I have to mention this kind of as the bad guy. You do have to have the ESRI licensing for whatever number of cores you create in the Amazon cloud. So
right, yeah.
So that you have to consider that.
Yeah, we have the luxury of, we don't have that problem. If you're under an ELA, that's certainly a good use of your ELA because you can scale it up and use as much CPU as you want in the cloud. This is that panel where you can decide. I said I just want to use one instance, but you could make it as many as you want there. And this is where you do the auto scaling. Then when you get done with it, you get a link to ArcGIS Server Manager. And you can log in with ArcGIS Server Manager. And in this case, I'll log in and kind of check out the cache status in ArcGIS Server Manager. So there's tools inside of Manager that allow you to access that.
I keep interrupting while this is loaded, but one other thing I want to add to what I just said about the licensing is if you want to get an Amazon machine for a short amount of time, there are shorter term licenses for ArcGIS Server that you could use for that purpose. You could talk to your ESRI representative about that if you need a temporary or short-term license.
I'm really going to be ready for the party after this.
Don't go crazy.
Yeah. Yeah. I won't be playing any dodgeball. It'll be great. All right.
With the EDN license, do you have access to some of these?
Yeah, you can take your EDN
Yes.
license up to the cloud. That is a viable option. Okay. Dev Summit Cache. That's really bizarre. All right.
There you
Yeah.
go.
Okay. No idea why that happened, but we'll just keep moving because my experience, any demonstration, the success of it is an inverse relationship to the number of people that are actually viewing it at that particular time. And I think this is a good example of that. There is my Indiana hillshade that's currently being processed. We can check, just like Sterling checked inside of ArcGIS Desktop, we can check the status of that right inside of ArcGIS Server Manager, and it can give you the same kind of status updates. In this case, it's doing a pretty good job. It's just cooking right along there, and it's showing me the number of tiles that it has created, quite a few there for the state of Indiana. So I'm going to take that service, and I'm going to just go over here to the REST endpoint. And I'm going to go over to, I kind of try to give both Chrome and Firefox equal time in my presentations, the two browsers. I don't know, maybe that was mean. But here I am in ArcGIS Online. This is what your organizational account looks like inside of ArcGIS Online, and I'll just refresh my content here, and we should see Indiana hydrography. There's that map service that was created, and I'll go ahead and share that with everyone. There we go. There's the map service, and I can go and I can start using that map service right away, even though that it may be, and this is my favorite part, he changed the default map on me. Thank you. Dan Haig, good friend of mine. All right, so if this is recorded, he's probably going to hear that. That's great. So now I'm going to add in that layer. I'm just going to search in my content. Injury, boy, I've been doing too much. Indiana hydrography, there it is. I'll add that to my map. And there we go. Something that worked pretty good today. That's good. There is that map service, and it can continue to be the tiles generated for it, and I can use it here in the map. Likewise, I can add layer from the web, and I'll paste in the wrong thing. Go back to here. And I'm going to just go right into that hillshade there. Probably shouldn't have done that. Nothing wants to cooperate with me today. No, I need to get that full URL. So we'll navigate in there to Indiana hillshade, and we'll add this to the map once it goes in. Yep. If it's not available yet, is it?
It,
You're in the process of generating that cache.
Right.
And it was at the layer it was moved into that file hasn't been created yet. Where's the data coming from?
Yeah, you just won't see anything. You don't see anything while it's being generated. It's just blank until, if you have like a no data tile like I talked about before, if you put that in there, you just get the no data until that data is available. Yeah, this is good. Really.
The reason he was able to be so confident at viewing that is because it takes so short of time to cache those first few layers. Hadn't gone down clear to the very bottom yet.
So we can see that it is cached. It is working nicely there. No, I don't know why it's giving me trouble in that services directory, but there we can see the two services that I was caching simultaneously, one in ArcGIS Online and one in that Linux box in the cloud. And we can zoom in probably pretty far to see what kind of cache levels. And there you can see that it's not quite done with that particular scale level, so it just turns off. And you could do fun stuff like, transparent. I'll press my luck. What the heck? That's something that I know works, so I'm going to go ahead and show it. Why not? After everything else that I went through here today. All right, that's it for my demonstration. I showed you caching image services, and I cached to both ArcGIS Online and ArcGIS Server in the cloud. With that, we've got about 5 or 10 minutes left for questions.